This tutorial is for 5th grade, Module 5, Lesson 20. In this lesson, we're going to look at the attributes of kites and trapezoids. We'll start by looking at the kite. In an activity done in class, the students discovered that kites have pairs of adjacent sides that are equal. And by adjacent, we mean sides that are next to each other or share a vertex. For example, in this first shape, I have these two sides that are congruent and they share that vertex. I also have these two sides that are congruent and they share this vertex. Knowing this, I can fill in the missing side measurements. So if this side is 4 centimeters, then I know that the adjacent side is 4 centimeters. And if this side is 6 centimeters, its adjacent side is also 6 centimeters. Let's go over to the next shape and fill in the missing side measurements as well. So here I have these two sides that are adjacent and they're both 7 centimeters. And these two sides that are both 4 centimeters. Now let's look at their angle measurements. The angles created by the adjacent sides that are not equal create equal angle measurements. So if this angle is 90 degrees, the angle opposite is also 90 degrees. I still have to fill in one more angle on my kite. Well, we discovered that when you have a quadrilateral, the 4 angles need to add up to 360 degrees. So right now I have 90 plus 90, which is 180. To that, I can add 60, which is 240. And that means I need 120 degrees to give me a sum of 360 degrees. If I go over to the other kite, I have 105 degrees on this angle. Opposite it would be another 105 degrees. This bottom angle is 100, so we still need to figure out the top angle. Well, if I add these angles together, I have 105 and 105, that's 210, plus another 100 is 310. And that means that this angle would be 50 degrees because that will give me the sum of 360 degrees. So you can see how we can find those missing angles by using the attributes of the kite and the knowledge that the sum of the angles of a quadrilateral would always be 360 degrees. Here I have written the definition of a kite. It is a quadrilateral with adjacent congruent sides. We're going to use that definition to help explain why squares and rhombuses also fall under the category of kite. If I go back to our definition of the rhombus, a rhombus has 4 congruent sides, and that's why a square fits in with that shape. So if we look at the adjacent sides of a rhombus or of a square, those adjacent sides are congruent. All 4 sides are congruent, but in particular, the adjacent sides are congruent. So that helps explain why the square and the rhombus fits in with the kites. And that's how we'll explain it. Squares and rhombuses have congruent adjacent sides. And finally, we'll back up that definition by showing the congruent sides on these shapes. Here I have more of a traditional kite, showing that those 2 adjacent sides are congruent, as well as these. On my square, these 2 adjacent sides are congruent, and these 2 adjacent sides are congruent. I just put 1 hash mark on them because they're all the same size. Same thing with the rhombus. These adjacent sides are congruent, and these adjacent sides are congruent, and all 4 sides are congruent. Next, we'll look at the trapezoids. At the 5th grade level, we will look at the definition of trapezoid that is exclusive. And what that means is we will say a trapezoid has one set of parallel sides. These 6 shapes are all trapezoids, so I'm going to mark the parallel sides on each one. Sometimes it's hard for students to see whether the sides are parallel or not. It's often helpful if they get out 2 pencils and line the pencils up along the opposite sides, and that will help them determine whether those sides would cross each other. You can see on this shape that the vertical sides are parallel because the pencils would never cross each other. But if I run the pencils along the top and bottom sides, you could see how eventually they would intersect or cross each other. So the top and the bottom sides are not parallel. And here's our definition for the trapezoid. It is a quadrilateral with one set of parallel sides. Now we need to explain why squares are not trapezoids. So if we think about a square, the top and bottom sides are parallel and the vertical sides are parallel. So that would be 2 sets of parallel sides. So that explains why a square is not a trapezoid. Squares are not trapezoids because squares have 2 sets of parallel sides. And this is just another example of how students can use the attributes of quadrilaterals to help decide the subsets of quadrilaterals and which shapes would fall into those categories.